We have covered the general forensic process and technologies used in Linux Unix forensics in previous units. Now we will focus on the forensic technologies used in investigating Windows systems. Recall that the first step of the general forensic procedure is acquiring evidence. Before 2008, the law enforcement officers and the incident responders typically followed the process of yanking the plug to preserve non-volatile digital evidence on a suspect computer and mainly focus on acquiring a disk image. With advancing encryption and malware, volatile data presented only in physical memory becomes crucial for recovering encryption keys and detecting malware for investigation. So since 2008, there have been a shift from dead forensics to live forensic investigations. Now let's move on to first study technologies for Windows volatile data acquisition. If a suspect machine is up and connected at a crime scene, volatile evidence such as running processes, physical memory, network connections, logged on users, etc., are available to be collected from the suspect machine. Since we are collecting volatile evidence directly from a suspect machine, we should use small footprint tools to ensure minimum disturbance to the state of the live system. Earlier, we learned a set of Linux Unix commands used to collect important volatile data and system information. Incident responders and forensic investigators use a parallel set of Windows tools to gather volatile data from live Windows systems for forensic investigation. I listed certain built-in Windows commands and free utilities here for you to try and practice by yourself. Some instructions are included in this unit's resources. Make sure to redirect the result outside of the suspect machine by using > or Windows netcat. So to display system date and time, we use Windows built-in tool date and time. And to display when was the system rebooted, we use a free utility called uptime. We also use PS tools, the PS info, to display system information. And we use a built-in IP config to check whether the network interface is running in a permissive mode. Look for unusual processes. We use task list or PS services. To list currently loaded DLLs, we use list DLLs. To view open files, we use PS file or open files. Show network connections, we can use fport or netstat. And to show logged in users, we use PS logged on or log on sessions. To view clipped content, we use pclipped, and to view logs, we use Windows Event Viewer. Next, I want to introduce a powerful forensic toolkit called Helix 3 from eFence. This tool has a collection of forensics tools for data acquisition, preservation, and analysis. While Helix 3 Pro is a commercial tool, they also have a free version, Helix 2009 R1. Helix 3 operates in two different modes. One is in a Windows Live mode, and another is in a bootable environment. Instructions for downloading the Helix 3 ISO version 2009 R1 and creating the CD are given in the course resources. When using the Helix 3 CD on a Windows suspect machine, it is a perfect example of a trusted forensics tool set that includes many forensics tools to collect both volatile and non-volatile data from a suspect machine without relying on potentially compromised internal tools and programs. When using the CD as a bootable CD, it runs entirely off the CD and only mounts the hard drives in read-only mode. In this mode, Helix 3 is used for in-depth analysis of the targeted powered-off systems. In the next video, I will demonstrate the use of Helix 3 in a live Windows environment to collect volatile information from a Windows system.